This video addresses problems 731 and 733 from the textbook. The Excel model used to solve problem 731 is shown on the screen. Currently, there's just arbitrary values of 10 for the decision variables. Solver will change these. So the problem is already set up in Solver, and you can see the setup here. For the rest of this video, we'll focus on answering the sensitivity analysis questions posed in the textbook. Once we click Solve, and Solver says that it's found a solution, to get the sensitivity report, we highlight sensitivity in the Reports section and click OK. The sensitivity report shows up on a separate tab. Let's look at some specific questions that were addressed in the problem. In problem 731, part B, says if a technical breakthrough occurs that raised the profit per unit of X to $8, would this affect the optimal solution? What we notice on the sensitivity report in the top section related to the decision variables is that the allowable increase is 8. A per unit profit of 8 would represent only an increase of 3 from the current objective coefficient, which is 5. Since 8 is within the allowable increase, the optimal solution would not change. What that means is that we would still, in the optimal solution, produce final values of 30 for X and 70 for Y. So the optimal solution would not be affected. What we do need to realize, however, is that while the final values for the decision variables might not be affected, the profit in the problem would be affected. Currently, the profit of the optimal solution is $510. If we still produced 30 units of X, but the profit increased by $3 up to $8, we would have an increase in profit of 30 times 3, or 90. The new total profit is 510, which is the original profit, plus the 90. We obtained this answer without doing anything except looking at the sensitivity report. The sensitivity report is useful because you can pass it along to others, and they can answer some of these questions yourself without having to change the Excel model. To learn how the sensitivity report works, it can be helpful to go back to the Excel model and make the change and can verify what happens. So for instance, in this case, we wanted to know what would happen if profit per unit changed to 8. And we can see that the calculation shows us that total profit would be 600. To verify that the optimal solution doesn't change, we could go back into Solver, click Solve, and see that nothing changes from the 30 and 60. So this validates what the sensitivity report tells us. Part C of problem 31 says, instead of an increase in profit for X to 8, suppose profit should have only been 3. Does this change the optimal solution? What we notice here is a change in profit to $3 would be a decrease of 2 from the current value. The allowable decrease is only 1. What the sensitivity report tells us here is that if profit decreases by 2 as proposed, the final values for x and y in the optimal solution would change. The sensitivity report does not tell us what these values would change to. We would have to go back, make this change in the model, and rerun solver. Our intuition should be that because the profitability of x is decreasing, the amount of x included in the optimal solution should decrease as well. Let's try this in the model. Change the profit per unit of x to 3. And we can see, in fact, that all of the production shifts to y in this case because x has become much less profitable. So we see that what happened is all production shifted to y, and the total profit is only $4.80. Let's look at the questions posed in problem 733 regarding this output. Question A says, how much could the profit on x increase or decrease without changing the values of x and y in the optimal solution? So again, we're looking here at the allowable increase and decrease. Profit per unit can increase up to $7 without changing the optimal solution, but can only decrease by $1 before the optimal solution should change. Profit per unit can increase up to 7 for x, but only decrease by 1 without requiring a change in the units of x and y produced to maximize profit. Although it's not addressed in the problem, we can see that the same holds for y. We can increase the profit per unit on y up to $1.50 or decrease it by up to $3.50 without requiring a change in the units produced of x and y to maximize profit. A range of values for the profit could be defined as 2.5 up to 7.5 if you wanted to take these allowable decreases and increases and adjust the objective coefficient. Question B says, if the right-hand side of constraint 1 were increased by 1 unit, how much would the profit increase? This is given to us by the shadow price. For constraint 1, the shadow price is 75 cents. So an increase of 1 unit in the right-hand side of the constraint increases profit by 75 cents. A decrease in 1 unit for the right-hand side of the constraint reduces profit by 75 cents. This is true for increases up to 120 or decreases of up to 40. Let's try this in the model. Well, we can tell what would happen to profit without changing the model. It's useful to use the model to understand this. What if we increased constraint 1 by 1 up to 121? You can see I have this cell here linked to the assumption up at the top. If we resolve, notice that profit has increased from $510 by 75 cents. This does require a new value of the optimal solution for the decision variables, and these values aren't available on the sensitivity report. Let's put the model back to the original solution. What if we decreased the amount available for constraint 1 by 1? Profit decreases by 75 cents. The values of the decision variables at the optimal solution have changed. Again, I'm just going back to the original model. Remember the allowable increase and decrease? What if we add, say, 41, or I'm sorry, excuse me, add, say, 121 to the right-hand side? That would be a total of 241. Well, what will be the change in profit? Now the profit increases to 600. The original was 510, so this is an increase of 90. But notice if we take 90 and divide this by 121, which is the number of units that we added, the change is less than 75 cents per unit. So changes beyond the allowable increase still do increase profit. It's just that the shadow price is no longer valid as a way to specify exactly what happens to profit. What we notice here is that all of the production in this case flipped to X. Question C is very similar, and you can do this type of analysis with question C, but it asks about a 10-unit change in the right-hand side of constraint 1. And we can see, just simply from the sensitivity report, that 10 is within the allowable increase, so we would expect to obtain $7.50 in increased profit because the shadow price is 75 cents. If we change the model to 130 as the available right-hand side constraint, constraint 1, we can see that this is the case. Profit is now $517.50. Hopefully this gives a little bit more insight into what's happening with the sensitivity report.